Okay, seniors, this is the last 2 pages of our project, and then we are done. So we'll go through these 2. I'll just get the top information done, and I'll give you time to work. And here you go. Confidence intervals. Do you remember what a confidence interval looks like? Okay, so you hate confidence intervals. So we start with, for proportion, it's called P. For mean, it's called mu. For a standard deviation, I don't think I give you variance, so I can cross this one off, but a standard deviation we call sigma. Okay, then all we need to do is find these 2 numbers that confidence interval has to live in between, right? Like we would say, it's not fair for me to say that 43% of all seniors have blue eyes, right? I would say probably somewhere between 40 and 45%. I would give you a range rather than giving you a definite number, right? That's what a confident interval does, okay? So, these are the formulas for the error that we do, okay? So for a proportion and for a mean, you do each one of those errors and you add and subtract from p hat. Some people were confused as to what these variables represent. Shall we write them out? Sure. So, what is P? What's the difference between P hat and P?
P hat is the sample.
P hat is the sample, and P is the population. Yeah. P hat's sample, P hat's population. The other way around. Anyway, Q hat is 1 minus P hat. We know that, right? N is the number in the sample. And then what is Z of alpha over 2? This is from the chart. That's the number that we look up on the chart, right? So you look up in the corner of the chart because we're on the Z chart. So it's like the 1.645 or 2.575 or 1.96, those numbers, okay? For mean, what does S stand for? Standard deviation, right? Okay. Standard deviation, N is again the number in the sample. Okay, and then T is from the chart. From the chart. Okay. Now, mean does have 2 different charts that you look up. Confidence interval for mean. There's 2 different charts that you look up. T chart is when N is less than 30. Z chart is N greater than 30. Yeah? Do we remember this? So this number right here that goes in the middle, like that, could be a Z number instead from the chart. It just kind of depends on which chart you're looking at. Okay? Good? Happy with that? Okay? For standard deviation, it's a little bit different because we don't add and subtract an error like we did in P and mu, right? Okay, we don't add and subtract error. This one, we look up the chi-squared right and the chi-squared left numbers because the chart has 2 different numbers on the chart, right? Okay, and this is where you flip-flop them. So the right one goes on the left and the left one goes on the right, right? Okay? And those numbers you don't actually square, right? Like chi-squared right, you don't square those in the formula. It's just that number, right? So this square is already squared. Does that make sense? Do you know what I'm talking about? These little squares are already squared from the chart. You don't actually square those numbers. You do have to square the standard deviation, which is this guy. Standard deviation, and then N minus 1 is just your number in your sample. Minus 1. So it's kind of like your degrees of freedom, actually. Right? N minus 1. Okay? And so you do that for each one of them and take the square root, and that's your confidence interval for standard deviation. Okay? Good? Are we super confused? Do we need to see something?
Yep.
You do? Yes?
First problem.
The first problem, like get you started on?
Yep.
The proportion of the N equals how many students in this class? 17. That are older than 18.5 years is this many. Okay, so we have to go to our chart and figure out how many people are older than 18.5. So Jackson is 1. Josh is not. MJ is. Erica is. Kelsey is. Lily is not. Ashton is not. Michelle is not. Ellie is not. Caleb is. India is. Keaton is not. Molly is not. Abigail is older than 18.5. Maddie is not. TJ is and Allie is not. Okay, so that is, you found 8. 8, but we have to put that into a p hat. So how do I make that into a p hat? 8 divided by 17, and that is what percent?
Ellie is
8 over 17?
47.1 or 0.471.
0.471? 0.471, which means that Q hat is 0.529. I have no idea. Yeah?
Yeah.
0.529. Construct a 95% confidence interval for the true proportion of Blue Hill seniors that are over the age of 18.5. Now, if I relate this back to your entire class, it is not fair for me to say that the entire class of Blue Hill seniors has 47.1% that are greater than 18 and a half years old. Because it might not be that. It's probably going to be a range. Somewhere maybe between 40% and 50%. I don't know. Okay? But we got to find that range. So we do error. Okay? Formula for error is Z. And we want to do Z at 95%. Somebody find the Z for 95%, would you? Is that 1.96? P hat Q hat over N. What is it? 1.96, okay? And then we do times the square root. P hat, we just found, 0.471. Q hat is 0.529. All over N, which is 17. And we do all that good stuff and we find the error. Somebody give me that number if you would, please. It's going to be like 0.0 something. Your error is usually somewhere between like 1 and 5%. 0.237? What?
That doesn't seem right, but
Really?
that's what I had.
0.237. Anybody else? Did you get that? Whoa, that's a huge error. 23% error? What? Why is it that big? I mean, I can believe that, but why is it that big? Yeah, we didn't survey very many people, so our error is likely to be high because the more people you survey, the less error you have. Okay, now that's what I add and subtract from what?
P hat.
P hat. So I take 0.471 and I add and subtract the 0.237 and I get these two numbers, right? Okay. So I don't know. I can't math in my head. I can add maybe 807.708. Subtract 432. I don't know. Check that bottom number, the subtraction. Somebody would. 0.471 minus the 0.237. We got. Yes? Yes? Okay, so what does this mean? Explain what this confidence interval means in your own words. What does this mean in your...
23.4.
We are. Start with. We are. How confident?
95%.
95% confident. That.
Between
23.4% and
70.8%
70.8% of
Blue Hill seniors.
BH seniors are what?
Older than 18.
Are older than 18 and a half. Okay? Now, that's not a very narrow range. 23, but somewhere between 23 and 70%. That's not a very narrow range. That's like, oh, that really narrows it down for us, right? But that's because we didn't survey very many people. Okay? So, all right. So, can you do 46, 47? Those are just mean and standard deviation. Should we go to the back?
Yeah.
Last page. Last page. Hypothesis testing. Okay? Now, this is the easy hypothesis testing where you're only doing one set of data. You're not doing like P1 equals P2 or mu1 equals mu2. You're doing like P is equal to 0.5 or P is greater than 0.5, that type of thing, okay? So to do your test statistic, this is your formula. To do for mean and for standard deviation, these are the values that you use, okay? The thing that people screw up all the time is the difference between P hat and P. So this is the sample, and this is the population. Which one does your claim go with? Your claim is always labeled as P. Okay, go down to the next one. What's the difference between X bar and mu?
Expert sample.
Sample, mu is population. Which one goes with the claim? Population. That's always the claim. Okay? This one. S and sigma. These two guys right here. Which one's the sample? S. And the population is sigma. And which one goes with the claim? You always label him with sigma, right? Okay. You guys know what N is. You know what Q is. And you know what what's this little alpha thing right here for each one of them? Your significance level. So like 0.05 or 0.01 or 0.10 or whatever that is, right? That's just your level of significance, okay? Make sure that if you have a tail, if you're doing less than. That's not us. What? Because these two are the standard deviations. I don't know. It's just like lumping these two together, lumping those two together, lumping the bottom two together. Oop. If you're doing less than, you're doing one tail. If you're doing greater than, you're doing the big tail. If you're doing equal to and not equal to, you're doing two tails. Okay? If you're doing two tails, you have to split your significance level, right? So if it's 10%, you have 5 and 5. If it's 10%, this would be the entire 10%. So 10, 10, this would be 5 and 5, right? That's how that would work if you had a significance level of 10%. Okay? Do you guys know what you're doing?
Yep.
Okay?
Just do 48 really fast.
We should do 48 together really fast? Okay? The proportion of the N equals blank students in the class. 17. In the last 6 months of the year, how many people are born July through December? 5?
Yes.
5? So 5 out of 17 is p hat
0.294.
0.294. So 29% of students are born in the last half of the year. Use a 0.5 significance level to test the claim that the majority are born, and this is confusing, in the first half of the year. I don't know. This is like Allie came and asked me this because I don't know if that's a typo or technically if 29% are born in the last half of the year, then the majority would be born in the first half of the year. Do we want to go ahead and say
Skip it?
no?
Skip it?
No.
We can take a class vote on it. You got a lot of mistakes on this package.
I know I do because I switched everything. The majority of seniors are born in the first half of the year. Okay, let's go with what it says. I told Allie differently, but you can leave yours. Okay. So if the majority of seniors are born in the first half of the year, then P, we're going to say equals 0.5, or we're going to say P is what? In this case, it would be less than 0.5, because if we're talking about majority is first half of the year, that would mean the minority is born in the second half of the year, so less than 0.5, okay? And then we'll do this tail here.
Wait, so we're not doing the greater than?
Okay, because here, this number is based on the second half of the year. And so we're saying the majority born in the first half of the year, which means the last half of the year, what we're talking about would be less than 50%. Does that make sense? Yeah. So, what percent goes in your tail? 5%. All 5% goes there. And then we have an imaginary 5% here. And 90% in the middle. Okay? All right. Do you want to do p-value method or critical value method?
Yes.
P-value.
P-value, so you like the 0% and 100% and 5% and 95%? It doesn't matter. It doesn't matter. We'll do it this way. 5%. Okay.
I hate this one.
I hate this one. Too
Go
bad.
here. No, other way.
The other way?
Run
Switch?
it back.
Okay, you can do it this way if you want to, Michelle. Okay. Okay.
Until you're smart enough, you can do it on your own.
Okay, so go to the Z chart, 90%. What are my cutoff marks right here? Go to the chart.
1.64.
1.645, so negative 1.645, and we really don't care about the positive 1.645 because that's the imaginary tail, but you can label it if you want to. And now we have to do the test statistic and be done, right?
Yeah.
Okay. So,
Error.
blah, 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 blah. Nope, there's no error here.
Oh.
Yep. So we have z equals p hat minus p over the square root of pq over n. Okay. So, what's p hat?
0.294.
0.294
Minus.
minus
P.
0.5 over the square root of, what's p?
Square root of
0.5 times q? 0.5
0.5. 0.5.
all over
All over the n. 17.
17. Okay, go. Negative something big.
1.6.
No.
8.
Is it?
No.
It's not that big?
I don't think I did that right.
You're fine. Negative 1 point what?
6, 9, 8, 7.
We'll go, so, yeah, 6987, so like negative 1.70. Somebody else get that? 17.
What the heck? Why do you have two numbers?
Does anybody else concur with that number?
Yes.
Yes? Yes.
Yay.
Josh concurs. Awesome. Okay, now what? Last thing.
You check to see where it lies.
Where does it live?
It lies between them, so it's a fail.
It does?
No, I'm just
Negative 1.7?
No, it lies in the thing.
Here's 0.
No, it lies in the left thing.
In the left thing, which means what?
It's not reject. I mean, fail, not fail, reject. It's reject.
It's reject, which means that it is less than 50%.
It is right.
So less than 50% of seniors
Is it?
live or are born in the second half of the year.
Is the bottom the claim?
The bottom one's a claim.
Yeah.
Yep. Claim is true. Reject. Reject H naught. Claim is true. Explain this conclusion in your own words. We said the proportion of what? Proportion of
BH
students.
seniors.
Yeah, BH seniors. We can go with that. BH seniors. What? Born in
Or born in the
second half of the year. What? Is what? Less than 50%. That's what we just found right here. Less than 50%. Okay? Good? Woo! Okay. You got like 4 problems left. Awesome. Let me look. You get out at 3rd period, 10:10. You got 20 minutes. Hey, look at that. All right. Goodbye, people watching the video.